Hi, my name is Kevin Lake, and this is my MAE ECE 535 demonstration. Today I'm going to be demonstrating a coil gun. The way a coil gun works is there's a coil which current flows through, producing a uniform magnetic field within the coil, thus accelerating and pulling an object into its center. Now, if the coil didn't turn off quickly to allow the object to keep going forward, then the object would just sit there like an electromagnet or a solenoid, which pulls something into its center and just leaves it there. So what I've done here is implemented an Arduino and a couple relays with capacitors and batteries that will allow me to set up the timing such that when the projectile is pulled to the center of the coil, right when it gets to the center, the coil will turn off, allowing the projectile to keep moving forward, and then with precise timing, the second coil will energize and give it an added boost.
Here is a video of the coil gun working. First, I will charge up both capacitors and then send a command to the Arduino through the serial interface to begin the firing sequence.
Okay, so let's dig into some of the physics that are happening behind this whole coil gun thing. Alright, starting over here on the left, I've got my Arduino, which is telling my circuit to fire and at what time. So if I open up that block, you can see I've got the circuit charging up, which I actually do manually by hand, but in the simulation it does it here. And then I've got two firing commands. So the first one is a little bit longer than the second one because on the second one the projectile is actually moving pretty quickly through the coil, so it doesn't have as much time to energize. Moving on. So if you look into the circuit dynamics, what we have really is a charging circuit here, which charges up the capacitor, and then I'll open that switch. So then what's left is really just an RLC circuit. You have the self-inductance of the coil, which is modeled here, the resistance of the wire, and then the switch, which I'm going to control with the Arduino. Coming back, if we look in Ampere's law, we have this approximation that we examined in lecture, which shows that the magnetic field generated is a product of the number of turns times the current divided by the length of the coil. So that's just an approximation. It doesn't take into account the edge effects, but it works for this simulation. Alright, so now we have a magnetic field in the coil. We have one actually staggering time. So if you look, the first one, the first magnetic field is generated, then the second one. Here, I'll zoom in on that for you. So it looks like we're getting about a little less than 0.7 Tesla there. So we'll have the first magnetic field spike, then the second magnetic field spike. Now, once the magnetic field is generated, I had to get a force to apply Newton's laws to the projectile. So the way I did that was through the conservation of energy. Now, this is a bit of a spider web, so I'm going to show you in MathCAD, which is much easier to understand the way I did that. So the whole principle here is that the change in energy between the empty solenoid and the filled solenoid can be divided by the length that the projectile moves to give us a force. So basically I got the energy density in the coil, and then I said the number of joules in an empty coil is the volume times the energy density, and then I said the number of joules in a filled coil is the volume of the air times the energy density plus the volume of the iron times the energy density divided by the relative permeability of iron. So using these equations, I was able to get a force of 5.9 newtons. It's nothing to write home about for this demonstration, but this can obviously be scaled up tremendously for actual applications. Now getting back to the model, I apply Newton's laws, which is just F equals ma, and that way I'm able to calculate the acceleration, the velocity, and the position of the projectile over time. And using the plots here of the position and velocity, then I can adjust the timing in my Arduino code to get the optimal performance. Alright, thanks everyone for watching. This demonstration showed that using Ampere's law, you can accelerate a piece of iron to some velocity Obviously, there's a ton of applications for this. You know, again, they would have to be scaled up tremendously for them to be actually useful. As you saw, the projectile didn't go really that fast shooting out of this coil, but if you were to add multiple coils or greatly increase the current, then you could scale this up to something that would be able to be used for tremendous power, either launching things into space or different military applications. So thanks for watching, and I'll see you next time.